right. Hello, everyone. I'm starting a little bit early just to make sure we don't run out of time. Uh, oh, let's see if I'm actually starting. Anyways, I want to make sure that this stream is smooth. If anyone's having any problems with the assignments or with the video, sorry. If anyone's having any problem with the video, please let me know and I'll try and look into it. Okay. Individually correct, like combined doc or anything like that. Okay. The individual reflections. Thank you. The individual reflections. I normally like having them as an individual document because really you're what you learned from doing the assignments. Even if you're working with a partner, it tells you something different. You're going to learn something different than your partner, and so they're not meant to be. If you've never taken a course with me before, where you've never taken a course that required a reflection with me before, they're not meant to, drive you crazy or make you cry or anything like that. They're meant to be fairly simple, straightforward things where it is like, I learned not to start the night beforehand. I learned that this is a pain in the ass, or I hate pointers, or whatever you want. It's meant to be for you. It's irrespective of if they just went into a pit somewhere, it still counts, right? It still would do the desired effect. We're still going to read them. But the point of them is for you to reflect on what you learned so that you know what you can take away from whatever the exercise was. And if you can't take anything away from it, either think longer about it or I screwed up, because there's always something to learn from every single assignment that you do. So that's what we're really aiming for. What is the point? Why am I asking about trees? I mean, when are you ever going to use a tree again? Everywhere. So that's sort of the point here. How to test the is connected function. Not quite sure how to set up and create a tree. So Joe, the tree and the connecting of the trees. The thing to point out is it's ugly and it's going to have to do for now. The trees are just manually connected up. There's nothing graceful or beautiful about it. You would have a function. You'd make a whole bunch of these nodes, like make an array of these nodes, and then you hook up individual nodes, and then that's it. That's the entirety of it. So the connecting of a tree thing is meant to just be, can you make a you just want to make a whole bunch of nodes and then just string them all together to make a tree data structure. And it's a manual operation. So you would say, node 2, I'm going to hook that up to node 3. Yeah. And then node 3, I'm going to hook up to node 17. Yeah. Whatever works for you, right? It's not, there's no hard rule. Now, you should have seen the other text file that I supplied. That text file covers a lot of the stuff. Like, that is one of the ways you could do a tree. Draw it out, by the way, if you're confused at what to do. If you don't know what to do, grab the piece of paper. Anyone that's a former student of mine knows I'm a big fan of, like, get out the paper, doodle something out, and try it out. And so draw out a tree, make sure you understand what it does before you start diving into code. Worst thing you can do is just dive into code. All right. Okay, man, I'd like to know the chest. Okay. Try creating a tree object, but that only creates one node, I think. Yeah, and then you manually hook up everything up afterwards. Parent and child nodes too. You don't define the parent necessarily directly. Will the synchronous meeting be posted afterwards? Yes, it is. It's actually automatically recorded. Do we string them together using an array? You'd make an array and then hook them up manually. So we can look a little bit about with this. Let's actually look at this in a related thing. So I already have. I figured we'd look for something analogous, and we actually have something very analogous in the lectures. So if you haven't seen this already, because we're working a bit ahead of ourselves here, hopefully it won't be confusing at all. We're going to look at linked lists. So linked lists is the topic that we're going to keep on beating to death over and over and over again this term, because we're going to keep revisiting it from different perspectives. So we're going to make a linked list with a struct. Fine. Then we're going to make objects and, make a linked list with objects. Fine. Oh, wait, let's make a different kind of linked list and use inheritance. And then we're going to use it for polymorphism. And then we're going to use for templating. We're going to use it all sorts of different places. The idea is this, and I like this image a bit more for linked lists. It is what a train is, right? You have not the caboose, that's the back, the engine of the train at the front, and then you hook up cars afterwards, right? each car has some kind of content being pulled along, but you need to know what's the next car in the line. You don't need the car in front of you. You're being pulled along, but you need to know who's hooked up behind you. So the main engine drives everything, and then if you know where the next one is, which the next one is, what the next one is. All you need to know is the data that you store and the next in the line. It's a conga line if you want to look at it a different way. So that's normally what you would do. And so yeah, so I have all sorts of little parts of the stories and stuff like that. But here is the thing I was trying to work on. So let me get a pen, and digital pen I should say, and it should start up anytime now. Here we go. So here is the idea behind a tree, if my thing doesn't die on me. Come on. There we go. So here's what we were doing. We would have something like this, and we'd have horrible back. What the heck is going on with my computer? Let's put 17 in there. It has some number associated with it, an ID. We're also going to have something like 4, and I'm going to try and ignore all of this crap going on with my screen. I don't know what's going on. And we have 5. Heck, we can even have duplicates. I can put another 17 in there. Maybe we shouldn't. Let's call it 117. That'll make it easier. We can make 2, whatever we want, right? That could be our tree data structure. This is our root up at the top, as in it has no parent. And so the start of your tree, you don't know if you have a parent or not, but whatever node you start with, that is your root. That's the base of the tree. And each of these is one step branch of the tree as I go down. And at the end, here's a leaf. Here's a leaf. 117 is a leaf. 2 is a leaf. 3 is not a leaf. 3 has another branch. It only has one branch, but it has another branch. Therefore, node 3, is actually considered just a normal branch in the tree, not a leaf. Leaves have no children, and so, but let's look at a linked list instead. So hopefully, we're at point 2. This is really driving me nuts here. 9. Let's say it points to nothing at the end. All right. A linked list is essentially what I have with a linked list is I am going to have a series of these structures, one after the other, and all they do is point to the next one. That's it. All I need to know is what data I'm storing and what I'm pointing to next. We'll actually look at the Visual Studio version of the code, but let's make a struct that does that, because it's going to look exactly like the struct for what we're doing here. So we're going to have, let's struct, I don't know what's going on with my video, LL node, I'll be consistent. And remember, if for anyone that's not done programming in a while and you're intimidated, I hope you're not, but if you are intimidated, one of my big things is just get out the paper. If you're watching a video and you don't want to code it up yourself, well, you should try and code it up, like simple things like a struct. Try coding it up yourself. And if you don't want to do that, at least get a piece of paper and try it on paper, right? Just get your hands dirty. There's no sense just watching videos and just letting it wash over you. You do not learn by osmosis. So get your hands dirty. My son's downstairs practicing the piano for the same damn reason. You can watch videos about people playing piano all you want. You're not going to learn to play the piano. You have to practice. So here's my struct LL node, and we're going to have some kind of integer ID. Hopefully it's not going to look that terrible all the time. And then I'm going to have, this is what I find a little weird. Let's put my semicolon in there. All right. This is going to make a linked list node. It automatically gets an ID and it gets a pointer to another node. I can't put another linked list node itself in there, but I can put a pointer to a linked list node. That's why we need pointers. That's why pointers are so powerful. Because I could just say, oh yeah, by the way, the thing I'm pointing to next, it's another linked list node. And now if I wanted to make a whole bunch of these things, I could say LL node N4 is equal to I'm going to make the struct just manually. Five, and then I'm going to put the pointer. Oh, we need the pointer to 4, so I should do the 4 first if I want to do that. Let's switch things up here. Sorry about this. Let's do this. I'm going to have to flip around the order of these things because I'm going to work in reverse order. So 9, put in a 9, and then 5. I'm going to point to that 9. So the ID that I have is the 5, and then I'm going to put a pointer to N9. Done. Node 5 points to node 9. If my linked list started pointing at the 5, I'd be fine. And then I can make one more. Let's make... I'm going to go nuts and scream if the screen keeps going like this. Oh, that's terrible. All right. And then I want to put node 5. This is me manually hooking up all the various things. I've made this linked list structure up here. And I can go to the next one, and the next one, and the next one. I can walk down my linked list as long as I want until I get to the end. How do I know I reached the end? It points to null. That's how I know I've reached the end. That's what we're doing with the tree. But the tree has one other thing. It has 2 children instead of 1. So instead of 1 tree node, you have 1 tree node pointer. You have 2 tree node pointers. If I had a tree that only had 1 child each time, it's a linked list. That's all it is. That's all we've done is instead of having 1 child, I have 2. So, and a graph is even more general than that, which is what we did last term and spooked a lot of people. Okay, so let me just get out of this for a second. I'm going to keep the ink annotations on this one. I am then going to go to our talk here because I found out something very, very bad last time around. W3X says it's help with C++ too. That's great. Although so do the labs. All right. Okay, LA1, that's what we were working right now. Maybe MS Paint or something will stop it from blinking. I'm really sorry about it blinking, but it's me doing a PowerPoint presentation and it's just not playing well with all the various screen capture applications as far as I know. But we do actually have, if you're wondering, we do actually have the annotations so you can look at them directly. All right, so here's the thing about all of this that we've been working on. So that's just the concept. We can look at the code in about 2 seconds now. I want to make sure that this is sort of making sense, but a big part of this is just getting used to doing this sort of thing and hooking things up. So your first week's deliverable is essentially just making a data structure. Then how do you find out if the 2 nodes are connected? Well, you check to see if the child of one node is equal to the pointer to the child is equal to this child pointer that we have around. That's it, right? So check both children. Is child 1 equal to this thing I'm looking for, the child that I'm looking for? Yes. Okay. Is pointer 2 equal to this thing that I'm looking for? Yes or no? Okay. Right? And you need one or the other. If either of those is a child, then you know they're connected. If the parent is connected to the child, then the pointer from the parent to child 1 or to child 2 is the other one. It's the address where this thing is pointing. So it's not like you can really screw that part up. It's a pointer where this data structure is stored. There's only one place where it's stored. So if I have 2 pointers and they are the same, you point to the same address, they have the same location, that's the same thing. They're the same. The parent and the child are connected because the parent is pointing to that other child, that other node. Generates a graph. Did I put a generates a graph? It should be generates a tree, although technically it is technically correct that if you generates a tree, then it does generate a graph, but that's semantics. So should it be generate a tree? Last term's thing was a graph, not a tree. So it should be generate a tree. Thank you. It's possible for a same number to link together. Great question. So you could have the same number in the list. You're not allowed to make this thing circular. So you cannot have the parent point to the child, which then points back to like the grandparent. You could, your code will let you do it. There's nothing stopping your code from doing that. It's not it's not a tree at that point in time. The tree can never point back up to, where was my thing here? Back up to the parent. So that's what you're not allowed to have circular references necessarily, but yeah, there's nothing stopping you from having the same number in there twice. It's going to be more confusing for you, so I'd suggest putting the same number in, like not using the same number, but yeah, it's fine. I couldn't find anything, especially about the syntax. So is it syntax that are keeping people stuck? Syntax for or statements within an if. I tried to do it yesterday. Okay, let's do that. Great. And maybe paint something that's okay. So here is linked list node. This is, by the way, the reason I wanted to double check on all the comments is I started giving that presentation to my 1400 class yesterday, not realizing it was the wrong class. And people were like, what's a linked list and what's a tree and what are you talking about? Oh, crap. So it was only about 5 minutes, but still, it was very embarrassing 5 minutes. Here we go. So here is, I'm going to make a brand new data structure. Why? This, in this case, is just covering my backside. We talk about this in the videos. I don't want to only store numbers. Maybe I want to store a string instead at some point in time. And if I wrap it up into some other data structure, I could just, change this from an integer to a string and everything just magically works still. It's just trying to think ahead and how my code will work. If I wrap it up, it's like wrapping up a Christmas present. You don't know what's inside anymore. And therefore you can, you swap things around. You can do all sorts of things afterwards. Here is our linked list node. This is what we were just talking about. You'll notice I have a little thing that you're going to unfortunately have to get used to about me. If I have a pointer to something, I will put P's in front of it, P underscore. This is me, or it is some programmers that do this, not all programmers. The reason I do this is because I want to know if this is a pointer, if it's the actual thing, like if it's the actual data structure I'm looking at, or potentially it's an array for all I know. An array is just a pointer to the front of a bunch of data. So the way you differentiate them, or one way to differentiate them, if you have a memory like I do, which is I have this terrible, terrible memory, the easiest way to do it is just put a P in front of it and I go, okay, now that's a pointer. Unless I really screwed up somewhere, everywhere I see P next, I know it's a pointer to the next. If I see A next, it's an array to the next, or the array is called next. If it just says next, it could be a node, it could be a pointer, it could be this, it could be that. I don't know what it is. So here is the data structure we're using. And all we do at the very end of the day, like we did with the tree, is point to the very front one, and that's it. That's all a linked list will normally do. Let's have a look at, let's see, insert at, do I have anything with a double or? Here's an if statement. I should have something with an or. I could easily give you an answer with this, but I don't want to just throw answers at people. Let's do one of these. Oh, is empty. Let's see if I have an is empty. Is okay. Let's make a brand new node here. Boolean is node empty, and I'm going to say ll node. So what do I want to make sure that this is what's true about this one? If p node is, if it's equal to null, and okay, if it's equal to null, and we're going to say if or double vertical bars. Why the double? People that did 1400 with me would have seen this and know what the heck. I always thought it was voodoo or like some kind of craziness. Why is it that we, instead of using a 1 or, we use 2 here? So since I can't get your answers right away, I want you people to think about it for a second. Why is it 1? Why is it 2 instead of 1? Well, if I do 1, it does a what's called a bitwise OR. We don't hit that often, but we do hit it. We're going to hit it when it comes to mouse flags and stuff like that. This is, it goes bit by bit through the two numbers that we have here. Whatever number is represented here, it could be a number, even if it's a string, it's a number in the system. Whatever the binary value is here, and whatever the binary value is here, and it goes bit by bit comparing the binary, bit by bit matching binary values for each, the 20th bit, are they the same? Hey, the 21st bit, are they the same? Are they both true? And it goes bit by bit through both of the numbers. That's what a bitwise OR does. This is a normal OR. This is saying if this is true or that is true. So I could say OR P node and is, if is node empty, let's say call it empty end. Yeah, there you go. Or P next is equal to null. I'm going to need a curly brace at parentheses at the end here. Return true. Is this thing empty or at the end? This means it's at the end. This means that it's empty. I would return true. Otherwise, I can return false. Oh, wait. You're wondering, where's the else in this condition? I could put an else in there. But if I say true, what happens? I immediately get the heck out of my function. If I say return true here, I'm done. I'm over with. There's nothing else that's going to happen after that line. So if either of those is true, I return true and I'm done. I won't see this line at all. This line will never be visited if I visit this line. And so one way of formatting your code that you might see from me is I'll do an if and then I won't do the else at all. I'll just have some kind of fall through. But let's make it a bit easier on ourselves. And I'm going to put this in there. And all right. So if the node is empty, or the null is equal to null, or if the pointer is equal to null, or if the pointer points to null as the next one, we know it at the end of our linked list, or the thing is not as an empty link, just a completely empty linked list. Okay, fine. And then otherwise we return false. This is us using an or statement in an if, like you might be doing for the assignment. All right, let's see what other questions you guys have. This is something I wouldn't normally, there's no need for that function, but I put it in there anyways. Which number would be the root in the PowerPoint presentation? Great. That would be 17. Okay. Generates a graph question. Okay, we already did that one. Okay. Or parent. What do you mean by or parent, Eddie? And this is oftentimes exponent, so it is logical and as well. Logical or is the other way around, by the way. That's a logical and, but at the same time, it's also an exponent, so they just went vertical bar. Logical and, let's do logical and here. Or, there you go. And there's logical or. Have to create our own tree for A1. Yes, you do. You can use the text file. The text file is for the next week. So the actual reading in the text file and doing all that crap is a lot harder than people want to give it credit for. And therefore, I wanted to keep it simple. The simplest thing for us to do, I want a minimal viable product, right? I have a tree. I want to test it first. And then I want to see if it actually works. So let's do is connected on my linked list as well. And yes, what is this arrow thing? That's the question. What does this arrow thing actually mean? It means follow the pointer and get the element. It's the same as a dot, but it changes things. So we can actually look at this. And you can use it in an if statement. It looks just like the dot. It's just instead of using a dot, it automatically dereferences it, gets the actual value, gets the actual thing, follows it to the address, and then gets the element. Okay. So let's have a quick look. Let's do is connected on a linked list, because what the heck. So let's make something like this. Boolean is connected. I'm going to have a link ll node n1, l node n2. I'm going to say that they're not necessarily parent and child. The other one that we do for the assignment, it's easier. I said one is the parent, one is the child. I'm just saying, are they connected? So if either of those are null, then we're going to say they're not connected. So if n1 is equal to null, or n2 is equal to null, return false. I would also like to point out, I do not have to say, is it equal to null? If I have a pointer that's not equal to null, then it is true. We talked about that in the videos as well. So I can technically leave that part off. Sorry, the whole thing. Just if n1 or n2. And that means, is n1 equal to null, not equal to null? If n1 is not equal to null, okay, if I say if not n1 or not n2. If this is a null, if this is pointing to null, then it's false. It is equal to 0. If it's not pointing to null, then it is anything else, not 0, and therefore it is true. And so you can get little shortcuts that you'll see in program. When you look online, you'll see all sorts of shortcuts like that. Okay, so if this is equal to null or this is equal to null, we'll return false. Great. So we now know that n1, if I'm here, I know that n1 and n2 must not be equal to null. I think that's fair to say, right? So what I could say, let's try this, a little bit of logic in here. N1, I'm going to get the next, so I need to get the next one, p next. Return is equal to n2, or, so is this statement true, or is n2 p next equal to n1? If that statement is true or that statement is true, what can we say? Well, then they're connected. n1 points to n2 or n2 points to n1, doesn't matter, they're directly connected. So if this is true or this is true, then I want to say that these things are connected. So it would return true. If both of these are false, so if this is false and this is false, so the only way this statement is ever false is if both of them are false. If either of them are true, then the whole thing is true. That's how OR works. If both of them are false, then, so you can pass the exam or pass the assignments to pass the course. If you fail the course, I can conclude two things. I can conclude you didn't pass the exams. I can conclude you didn't pass the assignments. So if I know that this is, if you fail both of those things, then the entire thing is going to be false. So I have to fail both of those, or both of those have to be false statements for the whole thing to be false. Oh wait, that means they're not connected. Done. I'm returning false. It's not connected. So I don't need a whole bunch of if statements. I just need to think about my logic a little bit. And that's nothing to do with coding. That's about thinking it through the problem to sort of simplify things. This is true if n1 is connected to n2, n2 is connected to n1, and if neither of those are true, then I'm going to return false, which is what I would expect. They're not connected. All right, let's see what other questions we have. Understand for part 2 of this assignment, question 9, text file. Should we be using this file for part 2? So for the following week, yes, you'd be reading in the text file itself. So the text file, I don't know if I have the text file readily available to me. That text file has a format of, here are the nodes in the tree, and this node is connected to these two nodes, if you look at the formatting. So so if I say that p node is equal to null is the same as no child is equal to null, meaning it doesn't have a child. If p next is equal to null is the same as saying one of the children is not, there's no connection to one of the children. We have an example in here, 3, one of the children is pointing to null, the other one's pointing to something. So you can't conclude that it's a leaf node. You have to make sure that both of them are pointing to null to get a leaf node, or for it to be a leaf node. Only one can be true. That's true. So N1 can point to N2 and N2 point to N, or if you do, it's not a linked list, right? It's just them pointing to each other. But one of them will be true. If one of them is true, then you know it's connected. You don't know the order, but that's fine. The logic still is sound. The start file, right? No, you do not have to work on use the start file, the text start file yet. You use it for week 2. Yeah, you're just trying to string things together and check it out. So how would I test this thing, by the way? So here I have is connected. Let's move this thing up here. I'm going to put a little, I want my little stubbies in here. I like my little, these are my function prototypes. I will eventually define this function. I'm going to eventually define a function called isConnected. When I do, we'll find out where it's located later. That's what the linking process is. But until I do, you know that there's a function called isConnected. So if I'm in main, I can say, hey, isConnected. Yeah, is it connected? So I inserted a bunch of stuff in here. So I inserted at the front, I inserted data 1, and then I inserted at the front data 2. So data 2 should point to data 1. This is, I just know how my code works. I inserted data 3 at the back, so data 2 is pointed to data 3. So what I end up getting here is 2, 1, 3, 4, 5. Should be the order of my nodes. Because I'm inserting at the front, that I insert in front of that one in the next step. Then I insert it at the back, and then I insert it at the back, and then I insert it at the back. So node 2, 1, 3, 4, 5. Okay. So what I should be able to do, if I wanted something really, this is the sort of quick and dirty way of doing things. I love assert statements. They are not normally meant for this kind of thing. An assert statement is normally, if the pointer is null, explode, right? Or if this thing is outside of the bounds of the array, explode. You want to find the error right away. You could do a cout statement or something like that as well if you wanted to do that. So I can say is connected, and I'm going to put and data 1, data 2. I also want to check the other way around, just because that seems like it would be reasonable. What kind of test would I want to do? I want to check to see if the reverse still works. I want to see if is connected. So is connected returns true in these cases. Beta 1 null, let's say. And I want to say, oh, that's going to be false invariably. I want to say, let's say I have a null perhaps. These are the kinds of things you could test if you want to test your code. That's at least how I would do it. And let's put the null in the front. Way too many tests, but it'll do. What other things do I want? I want to see that it doesn't work when they're not supposed to be connected. So data 2, I want to make sure, I want to put my data 2 in the front. And let's connect it, make sure that it's not connected to data 3. So that should be false. And also the reverse of that should also be false. Let's compile it. My assert is not working for some reason. What's wrong with that? Missing my closing paren. Missing a closing paren. I'm missing a lot of closing parens. Do I have that one? I have the other ones. Okay. Do I? Oh my God. Cool. Okay, let's see what I'm missing here. Is connected, takes in data, is a link, should be a, oh, it's LL data, sorry. It is, I need to have the actual data. It's not taking the right kind of data in there. So what do I want? I want a linked list to get these things. is equal to ll, so dot p start, p next. That's the node with the 1 in it. This p start is just going to be the node with a 2 in it. And I'm going to get the node with 3 in it by just going one step further. This, I point at the start, then I go to the next, and then I go to the next. So I go from the 2, the 1, to the 3. That is what I would expect here. And so this is going to be node 3. So I want to change all of these here. It's going to be a 2. Let's just do that. 2, 1, 1, 2, 3. And by the way, this is also why I didn't follow my own advice, but why you often check before you start just writing all of your code all at once. But, you know, what are you going to do? Okay, these are all pointers already, so I don't need that. It's a pointer to a pointer, which is not acceptable. And, oh, this one is, okay, that should be fine. And I need to get rid of those pointers. I should have written one test first the right way, because I thought they were pointers to these things, or they were the nodes themselves, not the data itself. Okay, so here is my data. I know that it's connected to node 2, connected to node 1, connected to node 3. What I want to do is go over here, and I want to touch over here on this side, or I can just push here and press F9 to turn on and off a breakpoint. If you've never seen that before, F9 is your friend. And then I want to actually run my code. So I compile it. I check to see if I succeeded. Nothing is broken. I don't just push the play button. I compile, I check, then I test. Because if I just compile and test and run it all at the same time, I won't see my errors, and I may be running the wrong code. I've seen enough students do that. I want to stop people from doing that. They'll stare at their code for like 40 minutes going, what the hell's wrong with it? I changed my code all these places, and I'm still getting the old values. And it's because they're looking at an executable that they made 40 minutes ago that they didn't realize they have a compile error, and they don't realize what the problem is. All right, I'm at my breakpoint right now. That's why my program didn't keep going. I'm going to keep walking through my program. This is step over, F10. So I'm going to step over and make sure that works. Make sure that works, that works, that works, that works, that works, and then move on. Now, I didn't have to use asserts. I could have done something else. I could have used like cout statements and but this is a quick and dirty, especially if you're in a rush. I know that this should be true in this particular context. I can throw it in there. An assert is normally supposed to be for all times this should be true, but we're not doing things like unit tests yet. So that's the reason I'm throwing in these asserts. This is just saying, I am saying that for all times, this should be true. So here's another test. Let's throw another test in here, and let's stop what I was doing. Okay, and let's do a cout statement just for giggles. Cout node 1 and 2 are connected, colon, and then I'm going to throw in what I have here. Is connected node 1 and node 2. That's going to resolve to true or false, 1 or 0. And I'm just going to put an end L in here. And what the heck's going on here? Because I'm not using IO. I'm using IOStream, but if you end up seeing this in your code everywhere, I keep on putting it in out of habit for my 1400 class when I shouldn't. If I throw this in here, this means every time I'm trying to use like cout or some of these really, really common things, it says, I know where that is. It's in the standard namespace. So when I say, hey, see out, you don't. Otherwise, if I don't have this in here, I'm going to put in STD, not standard library. It's not a sexually transmitted disease. Um, I snicker. I don't know who the person that came up with that and thought, hey, no one's going to notice that there's a combination. There's another word that stands for STD. Um, Computer scientist, I guess. Okay, so if you have all of this stuff, and let's see what my error is. Dereferencing null pointer p star ll. Null pointer p start. It shouldn't be a null pointer though, because I've already inserted a bunch of stuff. I could also assert ll.p start. What's this going to do? If p start is actually a legitimate thing and not null, it'll pass. Otherwise, it blows up and I find out, oh, this insert at front didn't work. If I wanted to just be paranoid. All right, let's build it again. But I'm looking for things like underlines, which, hey, there could be something wrong with my code. And I'm going to put another breakpoint in here, just right here, just to see what happens. All right, let's run it and see what happens. All right, I'm going to go one step further. And then I'm going to look at what I have here. Node 1 and node 2 are connected 1. So it's true. Great. I can do cout statements. That tests my code as well. Whatever works for you, but test. You don't write all your code and then find out later whether it works or not. Heck, you shouldn't write 5 different assert statements and then find out whether your syntax is right or not. Bad instructor, right? That is not. I should have done one little thing and I got cocky. I wrote a whole bunch of them and went, oh, no, they're wrong. I still only wrote 5 or 6 lines, right? Some people write their entire assignment and then find out later if it works and if it compiles. They're new to C. They're going to write their entire thing. No, write a little bit. Write your function definition or write your structure. Test it, make sure it compiles. Okay, now test your code to make sure it works. Okay, now move on to the next step. Move on to the next question. If you write everything all at once, you're going to have a really bad time. And yes, you can throw on a South Park meme if you want, on Piazza if you want it. Right? This is what doing this sort of incremental way of coding is the only way to keep your sanity, because it will bite you if you don't. So hopefully that makes some sense. Okay. There's been a lot of stuff after I left, so right, 21 can be true. Don't use the start file. No, you don't have to use the start file. Yes, and we're automatically recording and publishing them. It does matter how many leaves we have. No, it does not matter how many leaves you have. Go nuts. Don't go crazy like 400 leaves. It's a waste of your time. If you only have 2 leaves, you can't really test all cases now, can you? Right? So I'd put a bit more pizzazz in there, but you don't have to go. You don't have to go overly crazy on that one. Why does 2 have to come before 1 if they're insert at front? Oh, it's inserting at the front of the linked list, period. So if there is nothing if there's something at the front of the linked list, it will go in front of it. It says you go at the head of the conga line, or you go ahead of the line. That's what insert at front does, Eddie. So if you say you're going to the head of the line, it means you just step in front of everyone in front of that line. There are uses for that. When we look at stacks and queues, we'll actually see this in action. We'll use a linked list to represent a stack and a linked list to represent a queue, and then it becomes very useful. Heard right. Do we have to use the week 2 starter code? You do not have to use the week 2 starter code. If you want to, great. If you don't want to, great. It has to meet the requirements, and I'm hoping that the starter code makes your life easier. That's what it's there for. A lot of people go, oh, it's going to be so much harder. I don't like reading other people's code. And you go like, that's your life, right? If you're going to do anything with code, and I know, sorry to say it, but most of you will probably end up doing that because that's where the money is. If you're doing anything with code, then you need to be able to look at other people's code. You're not going to get, carte blanche. You're not going to get this sort of like, do whatever you, green pastures, I should say. You're not going to get whatever you want to do code. Most of the time you look at other people's code and either fix it or look at other people's code and work with it or use their libraries or something along those lines. You would never just get completely blind code, or rarely ever. I can't think of a single time when I had completely blank code where I didn't have to read another person's code. Even when we made a brand new game with making our own libraries and our own everything, we still had to look at other people's code, other developers, or we had to hook up to some kind of API or whatever the case is. So it's just good to look at other people's code. I'm not going to say my code's the best code to look at. I'm not going to say it's immaculate, but I was trying my best at least to make it explanatory, and hopefully it's going to help it somewhat. But no, you do not have to use it if you don't want. Other questions? So can I unpack anything, other topics outside of the assignment for you guys, or how to set something up, or just trying to think of what kind of topics you guys. I know that a lot of my former students for iTech 2100, so they did a visualization class with me, but they didn't take 1400 last term, and they're sort of like, oh my god, this is heavy stuff, because they took it with another instructor. And so things like pointers are perfectly normal to have trouble with pointers. I still have trouble with pointers, and I've been doing it professionally for 20 years. It's just normal. Whoever came up with that syntax, I don't get why I understand why they have the syntax like that, but it's not intuitive in my books. I always have to relearn it. And so there's lots of little things along the way that it might be going fast for you. My biggest comment is to just make sure, if you're looking at something and you don't know that topic, pause the video, practice, code up something, see if it works. Do the lab work, code up something, see if it works. And that seems to be the best way to just really enforce and cement your knowledge on certain topics. So, does anybody have additional questions? I mean, we have a lot of other topics here, but I think I actually hit almost every single one of them. So I might be wrong. So if I missed something, please pop it back up by posting another comment. About when we should be watching the videos, because I feel like I'm missing something. Yeah, I think a lot of people forgot Bit 1400, first of all. You weren't my student in Bit 1400, right, Stefan? The last name doesn't look familiar, but the first name does. So, and Connor, yeah, there's, how do I want to frame this? The videos are designed to be asynchronous because we are trying to be as accommodating as we can. We didn't set up a tree, by the way, Joe. We did a linked list, but I can go over that again as well. So let me address Connor's point first, and then we'll get to that. Yeah. So the videos themselves, they are meant to be self-paced. But there is the outline for when the actual topics are supposed to be covered, and so you're supposed to watch videos on those topics. But I would normally, my personal viewpoint on this is, I'd figure out what the topic is for the week, figure out what the videos are for that week, and just watch those videos for that week, and do the labs. Set aside the time during I know you already have a busy work week already, but set aside the time to do the labs. We're going to try and have the TAs in the labs, or at least us on call for when the labs actually occur, so that you can actually get help with the labs while the lab would have been going on. So that's Fridays, I know, but that's the best we could do. Watching the videos that week when you're supposed to be watching those videos. But I don't want to say like you have to watch it between 2 and 4, right? There's no benefit to you to force you into that, other than it forces you, much like a coach forces you to go in the pool, like from experience, unless other than the fact it's forcing you to do something, it's not more flexible for you. It sort of forces people into a routine that doesn't necessarily work for everybody. And so yeah, if you set aside what videos you need to do that week, and then so the videos are laid out based on the topic, and you know what topics are for that week, and so I would watch them week by week on a week by week basis. But I didn't want to say force it to particular weeks. You can look at the weeks themselves or the topics themselves as well. You will know though as well when you get to an assignment if you get to an assignment and it starts talking about objects and you don't know what the hell an object or a class is, then you know you need to watch the object-oriented programming series of lectures, for example. The arrow is this. The arrow here is for, instead of a dot, you use that for if you're dealing with a pointer. Instead of using a dot, you use the arrow, because otherwise you need to dereference the pointer and then use a dot. So this is dereference and dot all in one. That's what that arrow means. Go to where that thing is pointing and get get the p next. Go to where that thing is pointing and get the ID. Set up the tree code. Let's feel like it went over my head. Okay, so let's do that. Topic 1 is our first lecture and so on. Yep, and that's how we normally do it. Is leaf node? We went over that. Demo boy. Is leaf node? We actually talked about whether something is the end of a node, and hopefully it should be pretty obvious once you actually look at that. I'm not going to give answers. So during the class, I watched the lecture 1 videos, and I should have watched lecture 2 before this. We're on week 2, so you should probably have watched it Mondays. So the very beginning of we're still sort of covering review. We're still covering review effectively of 1400, and so there's a lot of stuff that's repeat, but I have no idea what Mia is. Oh, okay. I did bet at 1400 with Yermia. Okay. And so with different professors, they're going to be emphasizing different things. But I know I've been talking to the other professors for further down in the pipeline, and I know that David too was pleasantly surprised when he got my 2400 students from last fall. And they hit the ground running, and they did these fantastic projects. And he was like, "Oh wow, holy cow! They really actually know how to code." And so he was very, very proud. I'm hoping we keep on keeping up that standard of quality. But I pushed students, let's just say. Other instructors may not have pushed you quite as hard, and I apologize if I push you too hard. But I'm trying to. I know where the bar is. I know what you have to accomplish. So let's look at hooking up the leaves again under Joe's request. So let's have a quick look at, there we go. Let's do another version of hooking up the leaves. So I'm going to make a new linked list node. And I'm going to set that to be, I'm going to put the number 4 in there. Because it has the data. I want to put data 1 in there. My node connect 1. All right, let's call it that. And then we can do it this way. So this is going to make a brand new linked list node with whatever the data that's going along for the ride is. In our case, for the tree, it's an integer, but it could be just some data going along for the ride. Okay, and then besides that, so this is what our data looks like, right? And then I'm pointing to nothing. Let's make another one. And let's put data 2 in this one, and I'm going to call the new variable. I know very original names for these things. My node connect 2. Let's do it the slower way. Last time I was trying to put it in the right order to save myself some time. What I could do is this. My node connect 2. Let's connect node 2 to the other one. I'm going to point p next, and that's going to be equal to, so I'm just setting what the next value is going to be pointed to. It's going to point to, I can't put my node connect 1. That's an actual node. I need the pointer to that node. If I try it, you can even look at this. My node connect 1, it's going to barf at me. It should. There he goes. Why? Because it takes a pointer to the next node. Pointer to the next node. By the way, all of this code is on in the Google Drive that you have access to. I provided a link as well in CU Learn, in case you're worried about any of this. I also want to make sure say, point out where the sync lecture is. There we go. So this is, I have a linked list node. Oh, sorry, where is it now? I'm making a brand new linked list node. I'm making a brand new node, and then I just say, oh, by the way, where's next going to point? It's going to point to my node connect 1. I need a pointer to my node connect 1. So this is the address, the location in space, like your mailing address of where this thing is. It's not the actual object. It's saying where it's located. It's over there down the street. Okay, well, that's what I'm giving you. Where is next? Oh, it's it's down the street. And so now I can go and get it. So if I wanted to access, let's say, let's get the last element of this thing. So my node connect to dot p next, just to show you this in action. So I am now pointing to my node connect 1, right? This one points to this one, and then I can go one step further, and here's my arrow in action. Or let's say I want to get the data for this. So cout, I'm going to do a cout statement. The data is all right. Hopefully that should work. Let's see why am I getting an error with this thing? Cout statement. This thing. Let's compile it and see what happens. But yes, I want to stop debugging. I didn't stop debugging yet. I don't run it right away. I stop. I checked. Oh, I got a problem. Binary no operator. There's something weird going on with this here. Let's have a look. That's going to that. That's fine with the quotes. Why is that a problem? So now if I know that I have an error here, I'm going to look around for the local areas. I'm going to say, okay, that's my problem. Is this a problem? Let's just comment this out and see if another problem pops up. Nope, another problem does not pop up. Okay, let's see what could be the problem with this thing. My node connect. Let's. Okay. So that's not causing a problem. So why is this thing an issue? I'm going to do this as two separate steps here. Cout. Why is this yelling at me? It's because data's not. That's why. See, you can figure out what the heck's going on. What's wrong with this? Data is, oh wait, it is not a printable thing. It is one of these. It's one of these LL data structures. It has a number inside of it, but that itself is not a number. So let's get the number. Now it's satisfied, and we can get rid of what we had before, or we can just leave it that way. Let's compile, hopefully. All right, we can compile. So the issue was it doesn't know how to print just a data structure off. So I needed to get an actual integer or a character or something that it knows how to print off onto the screen. I do a little bit at a time and see what happens. Okay, and -2 is what the name node 1 is, right? Let's have a look. Node 1 was, let's see here. Here's what my printout statement is. Data 1 is the thing I'm connecting to, so data 1, and I go up to data 1, and it's -2. It's exactly right. Great. I can check my work. That's why we do it that way. All right. Hopefully, Joe, that the P next is in my data structure. Here's my data structure. Here's P next. Here's data. It's in the structure that I made. I rolled my own data type, right? I made a brand new data type called LL node. It has data. It has an element called data. It has a next. It is duct taping a bunch of different variables, types of data together. It does not declare pnext. This is just the blueprint. And so if you hadn't done structs before, this is new. This is the blueprint for what a node will look like. And when I make a node, it will have an LL data variable called data. It will have an LL node pointer called pNext. Every single LL node will have one of those things. And so here is the blueprint for LL node. And if I go down here, here is me making an LL node. Here's me making an LL node, and here's me setting it up by default right away. If you don't like that, because I always forget that one, you could say LL node, my node connect 3, let's say. My node connect 3 dot data is equal to data 3. My node connect 3 dot pNext is equal to null, let's say, whatever you want, right? You can make one of these variables and then set up the parts afterwards if you want. That's fine. By the way, one of the things you need to make sure you get used to is this kind of thing, dealing with structures and dealing with this arrow thing. This arrow thing right here. It's the same as the dot, but only it works for pointers. The reason I'm saying this is it will be everywhere the rest of the term. When we deal with objects, that's all you're doing all day, every day, right? Is dealing with dots or arrows to get to the function or the variables inside of an object. You'll see it all over the place. So this is just the preamble, the first instance where you're seeing this. Okay. All right. Linked list, I was getting ahead of myself with linked list. You're right. But I figured I had this analogous thing to the tree data structures. I wanted to give you trees to get you thinking about it before we dove into linked list. You could come up with that solution on your own. If you're struggling with it, I wanted to give you that sort of lifeline for here's something that's already been done. We're doing it for linked lists. It looks very, very, very similar to what we're doing with the trees. And hence, if you looked at linked lists, you can use it for your assignment. But there's something really gratifying to figuring out something yourself and realizing, hey, it's the well-trodden path that everyone took because it's the right path. So if you came up with the tree data structure on your own, congratulations, that's fantastic. Because it's, for a lot of people, they would be struggling with it. And if you got it, fantastic. So, all right. So, you might be one lecture behind, or more importantly, given the amount of, I know there was that screw up last Tuesday with all the dates and stuff like that, but the amount of people, the number of people that were super keen about registering for all these sorts of things, and the sky was falling in the first couple of days of class. I'm a little surprised people are a day behind. I thought you would have watched every single video back to back. Like, people were really keen on that first day of class. So I'm a little surprised on that one, but that's fine. It's perfectly fine if you're around this time. It would be probably a good idea to get to the end of, let's say, the linked list stuff, just to get a feel for it. You can work a little bit ahead of the course as well, which is a nice thing about doing asynchronous work. You can get a couple lectures ahead and maybe even get a bit of a hint on the next assignments, that sort of thing. Worst case scenario, you watch it again later to refresh your memory, which is not a bad thing. So you're not alone, Connor, but it's okay. It's okay to be confused. It's okay to not know something, and it's okay to be feeling rusty. That's why we're doing this. It's not because I want to be a sadistic jerk. I do, but it's a different reason. What I want to emphasize is, like, everybody needs just to practice. This is not me, like, I need to practice. Everybody, when you're learning something like this, it's just a matter of just going through the routine to make sure you make it your own. And so part of assignment 1 is just, it's forced practice. Because I know if we don't do this, we'll get to the exam and everyone will be like, what the heck was that? So assignment 1 sort of sets everyone's expectations of, like, you may have to work at this. That's fine. It's not impossible by any stretch. I'm sure every single one of you can do it. The people that I find can't do it are the ones that don't put in the time. They cram at the end and they go, why couldn't I do it? And you go, like, because you're cramming at the end. If you're here, it means you're probably going to pass just fine. So keep up the good work. All right. So is there any other, we're over time, I guess. I was going to go to potentially 5:30, but do people have any particular questions that they're left over? I wouldn't say you should be on strings. What time should you be on lecture 3 strings? I'd say start those next week. Strings are directly related to reading from the file as well, but you can do it with the old ways from 1400. So if you want to work ahead, if you're really falling behind or feeling behind because you took with somebody else, work ahead, because there might be stuff that we covered that I just say, oh yeah, they know how to read from a file, but you may not remember. And just, it'll give you a bit more practice and a bit more concentration on this course. But for anyone that's taken the course, strings, you've done enough string stuff, you should be fine for reading from a file. We'll get to string objects, the C++ idea of a string, in lecture 3, and that's, I guess, next week or maybe even the week afterwards. So it's if you allocate about at the usual hour and a half per assigned lecture, it approximately does you right. But on top of that, try and keep up with the, if you keep up with the outline was designed in that particular way. Oh, should you watch 3 before the synchronous lecture or after? The next synchronous lecture is next week, and you presumably, would you still be? Oh, that's a good question. I would argue that either one should work. I would watch it just beforehand, just because you get another refresher of things. Because this, I think the last part of this assignment be due next Tuesday. If assignment 1's done by next Tuesday, assignment 2 is involving strings. But it would just be like, you just got that assignment. So it depends on how you want to view things, but this is how most of these synchronous lectures will be, because the recorded lectures are what I would normally do in my lectures. The Q&A format is just to the whole reason we have this is to unstick people. That's the only reason we have these synchronous parts of lectures, to unstick people. The recorded lectures are what I would normally cover in class. And so I would design this to originally be purely asynchronous, but I wanted this synchronization period just to make sure that if people were stuck on any particular thing, or I can show people another way of doing a problem, or I can show people how to set up, a new project, or whatever the case is. I could go over trees again if people are getting confused. I wanted those options. So they're designed, the synchronous parts are optional, purely optional, and they're designed for Q&A to help you get unstuck. And it's due Monday, so you would have like 2 days worth of strings. It's probably a good idea to watch the strings stuff beforehand, but the string stuff for assignment 2 will be, I think they're purely stuff related to C strings, the stuff from 1400, which I don't know what other sections did, but we're talking things like printf, scanf, is it getS? Yeah, getS. GetS? Anyways, I always forget something. str for strings of strings, that sort of thing. Strings within strings, so substrings. Can I ask, what is this? These little exponent things, Jules. What are those supposed to? It's like it's due Monday, and that's a reminder what's above it, or what are those supposed to mean? I'm old. I've seen a bunch of you guys put those in there. I have no idea. I thought you were trying to show that it was an and symbol, but no, it's not. So you guys, can someone explain what the heck these chevrons are? Not chevrons. Cool. Nice. Okay. Man, old man Sprague strikes again. All right. Nice. I thought it might be that, but I'm like, it's due Monday. You agree with? Oh yeah, you agree it's due Monday. Nice. All right. So can I fix, rather than everyone just agreeing to lines above, Can I fix anything for anybody else? Anything else for people? I do not see anything else. I think we're having a lot of dead space because I'm waiting for people to make comments if they're going to make comments. Otherwise, what I'm going to do is I'm going to let you guys go. And if you have additional comments, you can just keep posting comments, and we can just. I want to make sure that you're feeling comfortable starting up. I'm not used to not being able to help people in labs and the like, and so this is hard for me as well. Please ask for help if you need anything. Okay. Thank you very much, guys. Cheers. Have a good one.